Okay, so we're given this position equation, right? And we're supposed to find the point at which the particle changed direction. Now let's just define what that means. What does a change in direction mean? So a particle change in direction would basically mean that the velocity is zero at a certain time point or more than one time point, but acceleration is not zero at that same time point. So this basically means that we have to use the x of t equation to find the velocity equation and also the acceleration equation. All right, so vt just means the derivative of x of t. So it's going to be 3t squared minus 24t plus 36. And let's now differentiate the velocity equation to find the acceleration equation to be 6 of t minus 24. Now, let's graph both of them to see where the velocity is equal to 0, okay, and where the acceleration is equal to 0, right? We can graph them, we can do it the manual way. Right now, I'll show you the manual way, followed by the graphing way, so you can learn both. So, here we should be factoring to find the value of the t, but I think before that, to make our life easier, we can simply divide every single thing by a 3. So now we can say 0 is equal to t squared minus 8t plus 12. And now we can factor. So we're going to have t minus 6 and t minus 2. So 1 time t is 2 and 1 time t is 6. Okay, these are the points where the velocity becomes 0. And here we're going to say basically 60 is equal to 24, and so t is equal to a 4. That's where the acceleration is equal to a 0. Could I have done this using Desmos? Of course, let me show you how. And so in Desmos, I would go ahead and I would grab the velocity equation, 3x squared minus 24x plus 36. And as we can see, the velocity is hitting the x-axis, which means 0 velocity at 2 points, which are the 2 and the 6. And now it's going to graph the acceleration equation, which was a 6x minus 24. And we can see it hits the x-axis at 4 and 0. Okay. So the velocity is 0 when the time is 2, and the velocity is 0 when the time is 6, and the acceleration is 0 when the time is a 4. So because the times where the velocity is 0 is not the same time where the acceleration is 0, we can now say that the particle changes direction at t2 and t of 6. So let me show you in the graph. So on the graph, the velocity was positive here because it was above the x-axis, and then it becomes here negative. Okay, so now it changed from positive to negative at the time of 2, and then it changed from negative back to positive at the time of 6. So the velocity goes from positive to negative or negative to positive. This is considered to be a direction change, essentially. Okay, for part B of the question, it says, how far does the particle travel between the 8th and 10th seconds? So the particle travels a certain distance between the 8th and 10th seconds, and we're supposed to be finding out what that distance is exactly. So, to do so, let me show you the two scenarios we have to adhere to. So we got two scenarios here. The scenario that the velocity is 0 at the time and the time interval provided, and we must be following this equation, or the velocity is 0 at the time that is not in the time interval provided. Let me show you what that means. Now, if you recall back in part A, we saw that the velocity was equal to 0 at 2 times 2 and also a 6, right? And so our velocity is 0 at the time, which is not in the time interval. Because what's the time interval between 8 and 10? Our velocity is 0 at 2 and 6. So if that's the case, it basically means that we have to use this equation, which is the simpler version of things. Now, let me show you how that's going to be done with this equation. So we will just say x at the time of 10 minus x at the time of 8. That means you must go back and you must replace every single time here with a 10, apply the equation, minus replace every single time here with an 8, and apply the equation. So assuming that a calculator is allowed, I'll come and put my equation here. I'll put x cubed minus 12x squared plus 36x plus 18. I'll come here on the sign and I'll be putting a table. And I'll ask it for the x of 10, it's 178, and the x of 8, which is 50. So now when x is 10 minus x of 8, that basically means 178 minus 50, and I'll be getting 128 as my answer. Now let's go on to part C, where it says, how far does the particle travel between the first and fifth second? We must be using now this one here. Why? Because our velocity was 0 at the time of 2 and the time of 6. And now our interval is between first and fifth. So we're going to go from first, then to a time of 2 where the velocity is 0, and then all the way to the fifth. So now we should do the following. We should do x of 2 minus x of 1, absolute value, plus absolute value again, x of 5 minus x of 2. Okay? And now I can use Desmos for the results. So now in Desmos, I'll be asking it for the x of 1, for the x of 2, and also for the x of 5. And I'm going to say we have x of 2 minus x of 1 in the absolute value, plus the absolute value of x of 5 minus the x of 2. So, x of 2 is equal to a 50 minus 1, which is 43, within the absolute value, plus x of 5, which is 23, minus x of 2, which is 50, absolute value. We'll get 7 plus 27, which is equal to a 34. Okay, for part B of the question, it says, how far does the particle travel between the 8th and 10th seconds? So the particle travels a certain distance between the 8th and 10th seconds, and we're supposed to be finding out what that distance is exactly. So, to do so, let me show you the two scenarios we have to adhere to. So we got two scenarios here. The scenario that the velocity is 0 at the time and the time interval provided, and we must be following this equation, or the velocity is 0 at the time that is not in the time interval provided. Let me show you what that means. Now, if you recall back in part A, we saw that the velocity was equal to 0 at 2 times 2 and also a 6, right? And so our velocity is 0 at the time, which is not in the time interval. Because what's the time interval between 8 and 10? Our velocity is 0 at 2 and 6. So if that's the case, it basically means that we have to use this equation, which is the simpler version of things. Now, let me show you how that's going to be done with this equation. So we will just say x at the time of 10 minus x at the time of 8. That means you must go back and you must replace every single time here with a 10, apply the equation, minus replace every single time here with an 8, and apply the equation. Now, assuming that a calculator is allowed, I'll come here and I will write my equation. So I'm going to be writing x cubed minus 12x squared plus 36x plus 18. And now I'm going to be clicking on this sign here, or sorry, this one here. I'll be putting a table, and I'm going to ask it for when the x is 10, how much is my y? So assuming that a calculator is allowed, I'll come and put my equation here. I'll put x cubed minus 12x squared plus 36x plus 18. I'll come here on the sign and I'll be putting a table. And I'll ask it for the x of 10, it's 178, and the x of 8, which is 50. So now when x is 10 minus x of 8, that basically means 178 minus 50, and I'll be getting 128 as my answer. Now let's go on to part C, where it says, how far does the particle travel between the first and 5th second? We must be using now this one here. Why? Because our velocity was 0 at the time of 2 and the time of 6. And now our interval is between 1st and 5th. So we're going to go from 1st, then to a time of 2 where the velocity is 0, and then all the way to the 5th. So now we should do the following. We should do x of 2 minus x of 1, absolute value, plus absolute value again, x of 5 minus x of 2. Okay? And now I can use Desmos for the results. So now in Desmos, I'll be asking it for the x of 1, for the x of 2, and also for the x of 5. And I'm going to say we have x of 2 minus x of 1 in the absolute value, plus the absolute value of x of 5 minus the x of 2. So, x of 2 is equal to a 50 minus 1, which is 43, within the absolute value, plus x of 5, which is 23, minus x of 2, which is 50, absolute value. We'll get 7 plus 27, which is equal to a 34. Alright guys, so we have a volume, and you want to find the equation of the rate. If they say a rate,
Acceleration?
differentiate. So if they say Vt, you must find dV over dt. Would you know how? What was, look, if I said I have a y, and I want to find dy over dx, what did that mean before? Differentiate. So if I have a v, I want to find dv over dt. So differentiate. Differentiate this equation. So 16t minus 32. That's it. If they say rate, they mean differentiation. Look guys, if height is equal to negative 4t squared plus 24t plus 50. Can you guys find dH over dt?
Like differentiate it.
Yeah. Which, by the way, is going to be the rate of change of height. The rate of change of height. No one said anything about making it 0. Sorry, bro. Okay. Here we have a circular pool of water whose radius is 4. This pool of water is expanding at the rate of 16 pi square inches per second.
What do you mean expanding?
Expanding means changing.
Exactly.
Maybe there's, rain pouring into it.
Yeah, not the pool.
The pool is expanding.
How is expanding? It's like
Right now, if I have a small drop of water and I add water to it, it's going to become what? A bigger
but that's the water.
spot
not
of
the
water.
Pool. That's water, not the pool. Exactly.
A circular pool of water. They don't mean pool as in like swimming pool.
Oh, okay.
Yeah. So it's expanding at 16 pi square inches per second. Who knows what square inches per second is a unit of? Area over time. Because area is square inches and time is second. We essentially have here dA over dt. The change in the area over the change in time. So the change in the area over the change in time is equal to 16 pi. At what rate is the radius expanding? Which means dr over dt. Now, since you guys know math, can someone here smart tell me the area of a circle?
360.
Area of a circle. You're taking the SAT on August 23rd. Area of a circle. The equation, you're taking it too? You're taking it too?
Oh.
Half the class is taking it.
So it's A equal to pi R2.
Pi r squared, you mean?
Pi R squared.
Now, please differentiate everything. What do you get? dA over dt pi. R squared becomes 2r times dr over dt. Y over dt? Is that what you're asking? Well, when you differentiate r, what do you get? Change of r. And since we have change of area over time, you must have change of radius over time.
Wait, so how do we know that we have to use like the circle equation for this?
Because this is circular.
So why are we differentiating it?
Because they said the rate of, and rate is differentiate.
What if it's like a cube?
We'll deal with it too.
Like we're gonna write the equation of a cube and then
Yeah.
we're gonna differentiate it?
Yeah.
Oh.
So we're going to have d over dt is equal to pi times 2r times dr over dt. Are we already given d over dt?
Yeah.
How much is it?
16 pi.
16 pi is equal to pi times 2 times r, which is 4, times dr over dt. Can I cancel the pi with the pi? Last time I checked, I could. 16 over 8, 2. Will this get you a full mark?
No,
Why?
it's not like numbers.
Because you did not write the units. inch per second. Always write the units for them.
And where?
In the end,
Like, what do you mean? Like, I'm gonna write 2 equals to dr over dt inch per second.
yeah,
Why did you write it under the 2?
because I don't have any space. Oh yeah, they love this one. Oh yeah, they do. Actually, they do pretty much. They do. So it's okay. This was your first encounter with dA over dt or dr over dt. Not your last encounter though. Oh, when we differentiate the r, it becomes dr. D for derivative. Yeah. So, like, you know how we had dy over dt or dy over dx? Now it's dr over dt. Same concept. Over dt means per time. Per time unit. You know what I mean? Smart. Let's do another question right now. Guys, we have a 25-foot long ladder leaning against the wall. Here's the wall. And here's the freaking ladder leaning against it. Whose length is how much?
25 foot.
If the foot of the ladder is sliding away from the base, so dx, I'll call the foot dx, sliding at the rate. You cannot say x, you must say dx over dt. Why do I say over dt? Because they say per second, which is a time unit. So dx over dt is going to be 15 foot per second. How fast is the top of the ladder sliding down? So when ladder slides away, the top also slides down, correct? So the dy over dt will be sliding down. How fast is the top of the ladder sliding down the wall when the top of the ladder, which means from here all the way to here, is 7 foot? Do we have a right triangle here?
Yeah.
Smart. We have a right triangle whose hypotenuse is 25, whose height is 7. Please find me the x. Find me how far is that ladder from the wall.
Do we need to use tan cosine?
We're going to use x plus 7 squared.
Pythagoras, as
Okay.
Yasin would call it.
So,
No, it's.
we're going to do x plus 7 squared.
Sorry, a square plus b square equals to c square.
And
But we don't plus them.
So we're going to do 25 squared is equal to x squared plus 7 squared. 25 squared minus 7 squared is equal to x squared. X squared is equal to... Try it out, please.
With calculator?
With... Your nightmare's over. Now use one.
4.
576 square root 24. That's the first stage. The first stage is done. Now we have a right triangle with all the dimensions it has. A 25, a 24, and a 7. Let's go. So this is the y, and this is the x, and this is the L. Question: when the ladder slides down, does the length of it change?
No.
No, it stays the same length. But the height from the ground will change. And the height, and distance from the wall will also change. Change means we can differentiate it. So we're going to have dy over dt. We're also going to have dx over dt. But will its length change? That means that dl over dt will be a 0.
Wait, because it doesn't change, it's going to be 0.
Yeah. So far, so good. So the length change, the length is going to be not changing. It's one ladder. So dl over dt is going to be 0. The height of the ladder from the floor will change. The distance of the ladder's base from the floor is also going to change. Now, we're going to say L squared is equal x squared plus y squared. You guys know this equation, don't you? It's the equation of a Pythagorean theorem, but without the square root. First time you guys see it? All right. Let's now differentiate. So what do we get?
2L is equal to
Whoa.
2x.
2L dl over dt is equal to 2x dx over dt plus 2y dy over dt. Can I divide now everything by 2? Is that possible?
Yeah.
Yeah.
It's dl over dt as well, but you said that L is not going to change.
Yeah. So L was 25, and dl over dt is going to be a 0, like he said. And x is 24. Dx over dt was given in the question, wasn't it? Can someone here smart tell us how much was dx over dt? You will get a candy if you get it right.
What was the question?
What was dx over dt? It's not 24. X is 24.
Okay, so
50.
How much is dx over dt? Do you want the Hershey's? Answer the question correctly. It's in the question. Look at the question. Example 9. So dx over dt, as given by the question, is 15. Plus y, which is 7. What's dy over dt? We're looking for it. So we're going to have 0 minus 24 times 15 is equal 7 dy over dt. Now, what is 24 times 15? 360. So dy over dt is negative 360 over 7. We keep it like this. We keep it like this. Oh no, one more thing left. The unit. Foot per second. Can someone here smart tell us why it's negative? This dy over dt, why is it negative? Because decreasing, because the ladder is simply now, look, ladder was like this, now it's becoming like this, then like this, like this, like this. So it's decreasing in the height from the floor, right? So this negative means decreasing height from the floor. Okay, excellent. We got the question right with your help. Next question. Look, right now we're dealing with volume because they say cubic inches. We're also dealing with area. Let me give you both. So for a sphere, the volume is 4 over 3 pi r cubed. And the area is 4 pi r squared. The sphere is expanding at the rate of 60 pi cubic inches per second. Expanding means changing, means derivative. And since it's cubic inches per second, that means we're dealing with dV over dt. Differentiate, please. So 4 over 3 pi, 3 goes down, r squared. 3 with the 3 go away. So you're going to have, now instead of dV over dt, we already know it's 60 pi. So 60 pi is equal to 4 pi r squared. Cancel the pi's, and 60 over 4 is... Don't forget to put dr over dt. Now, how much is the r in the question? 4. So 4 squared dr over dt. So 60 is equal to 64 dr over dt. So dr over dt is equal to 60 over 64. And what's the unit going to be for dr over dt? It's inch per second. Now, we want to find the area. Actually, you want to find how fast the area is expanding. How fast means derivative. So you must now differentiate this guy. Why is everyone on a diet when I want to be on a diet? Stop copying me.
Give me the other one.
Hershey's?
This guy, he was doing the other one.
You're not supposed to eat. You have acne.
Huh?
It will get worse.
Said he was doing the other one. Like, inshallah,
TA.
whoever eats it gets sick.
Oh god. 4 pi 2r dr over dt. Now, d over dt is the how fast is the surface area expanding? 8 pi. We already know what the r is, it's 4. And we just found dr over dt to be 60 over 64. Okay. And now if you do the math with a calculator, you will get 30 pi. Can we do it without a calculator? We could, because 8 times 4 is 32. 32 divided by itself is a 1. 64 divided by 32 is a 2. And 60 over 2 is 30.
So what's the unit, by the way?
Well, it's the change. Look, what's the area unit? Inch squared. What's the time unit? Second. So you're going to say inch squared per second. Yeah. You okay? You're standing. The back thing?
Kind of, yeah.
How can your back hurt from sitting?
I don't like these chairs.
Okay. So other chairs hurt your back or no?
It depends on the type of chair, to be honest. I'll just
Okay.
bring my chair.
There are types. Alright guys, move on. For this question you have a tank that's conical in shape, standing on its vertex. So it looks like this.
So what kind of tank is that?
Water tank. See? Water. It's getting filled with water at the rate of 18 pi cubic feet per minute. That means dV over dt is 18 pi. Can someone smart tell us how I knew it was dV over dt they're referring to? Because cubic foot per minute. Okay? The tank has a height of 30. The tank has a radius of 15. How fast is the water level rising? Water rises with a height. How fast it's rising? That means they're looking for dH over dt. When the tank has water to a 12-foot depth, that means the height is 12 foot. Are we feeling smart? Because if you don't feel smart, you'll have less chance of a higher grade.
Wait, so the equation was 1 over 3 pi r squared h?
Equation for the volume is going to be 1 over 3 pi r squared h. But let me teach you something cool. You have two dimensions here, don't you? You have h and you have r. You cannot have both in the equation.
So use H instead of R.
Use h instead of r. So what does that mean?
I don't know.
You replace the r with the h or replace the h with the r?
Place the R with the H.
Smart.
What are you guys?
Look, since we're looking for the dH over dt, we cannot keep both h and r. You must remove the r. Like the r in this equation has to be changed to something else. Because you're looking for the dH over dt.
So why can't
So you must remove the r because you will get dr over dt. Alright guys, so we can't have r and h together. We must only have h. Can someone here intelligent tell us why? Because we're looking for the dH over dt. So you cannot keep the r. Now guys, r is 15 and h is 30, correct? So is h equal to 2 times r? Because 30 is equal to 2 times 15, no? Yes?
Should we do H divided by 2?
Yes. So h divided by 2 is equal to r. No? Okay. Guys, imagine if I have x of 6 and y of, give me a number, 3. What do we say? We can say x is equal to k times y. We could. So x is 6, k is unknown, and y is 3. So k is equal to 6 over 3, which is 2. So essentially, you will say x is equal to 2 times y. Is that applicable? Do you guys get that part? It's just math.
why
Let's-
do you put a k?
It's a constant. We have to find the constant. So like imagine you're going to say h is equal to kr. 30 is equal to k times 15. So k is equal to 2. So I'm just going to say that h is equal to 2 times r. But my goal is to replace the r with h. So I'm going to say instead of the r, put h over 2.
Okay.
So I'm going to say volume is equal to 1/3 pi r squared. And instead of the h, instead of the r, put h over 2. wait,
We have the H.
the h. So that the r, put h over 2 squared times h. So now we're going to say volume is equal to 1/3 of a pi h squared over 4 times h. So volume is equal to 1/12 pi h cubed.
Wait, where did you get 1/12 from?
Because 3 and 4 are both in the bottom.
2,250.
No, wait. Now we have the equation for the volume.
Yeah.
Now what do you do with it? Now you can differentiate this equation. We have a tank for water storage, right? The tank is placed on its vertex. That's what it looks like. Have you guys seen those? I have.
It's usually like a cylinder.
No, they're used in Mazara. Yeah.
Never seen it.
Never?
You have like the cylinder one.
Sir, there is one for France. They put another in France, but
I've seen it. Anyways, so it's getting filled with the water at the rate of 18 pi cubic feet per minute. Cubic feet. Is that area or volume? Cubic feet. Cubic. Volume. So cubic feet per minute means dV over dt.
Sir, what word should we look out for if it's area?
Square feet. The height is 30. When the height is 30, radius is 15. How fast is the water level rising? So dH over dt is how much? When the water is 12 feet deep. That means when the height is 12 feet. Now my equation for volume of a cone is what? Can someone tell us? 1/3 pi r squared h. Now since I'm looking for dH over dt, I don't want to keep r as r. And instead I must put it as an h somehow. So h is 30, r is 15. I can say h is equal to 2 times r. So 30 is equal to 2 times 15, correct? Okay. So h is equal to 2 times r. So r is equal to h over 2. Now back in our equation, 1/3 pi, instead of r, put h over 2 and square it. And now we're going to have volume is equal to 1/3 pi h squared over 4 times h. So volume is equal to pi over 12 h cubed. Now we're going to differentiate. So we'll get dV over dt is equal pi over 12 3h squared dH over dt. We already know that dV over dt is equal to 18 pi. And 3 divided by 12 is just a 4. H squared. They gave us the h in the question to be 12. This is when the height is 12. So 12 squared. We're looking for dH over dt. Yeah, so we're going to have 18 pi. 18, the pi's go away. So we're going to have 18 times 4 is equal to 144 times dH over dt. So dH over dt is equal to 18 times 4 over 144. Now what's 18 times 4? 72 over 144, which is half inch per minute. We did this together. It was a group work. Is it inch? Actually, foot. Foot per minute. Okay. How easy is that? Are we still in love with unit 4? Then next one. All right, guys, so circle is increasing at the rate in area at the rate of, that means we have dA over dt to be 16 pi. How fast is the radius increasing? That means they want dr over dt when r is 2. What was the area of a circle again?
A is equal to pi r.
Let's now differentiate. So A becomes dA over dt. R squared becomes 2r. Now instead of dA over dt, you just put 16 pi. Pi times 2 times r being a 2 by itself. So 16 pi over 4 pi.
The pi cancels out.
Uh-huh.
Divided by 4.
Mm-hmm. And so 4 is equal to dr over dt. What's the unit going to be? Inch
Inch
per second. Are we smart?
No.
I'm feeling it. I'm feeling it. Like, it's just, I'm feeling it.
Feeling what?
The intelligence in the room. Like,
Just go
we actually need to
stupid.
contain it. Like, it's actually gonna pop.
Right.
I'm saying intelligence. Like, you know, when you inflate a balloon, it's gonna pop at some point. You put too much air, you put too much intelligence in it, it's gonna pop. The doors are gonna pop. That glass is gonna break. Remember the slamming of the door? Someone opens that door, this glass starts to slam somehow. I think I fixed it, or I tried it.
Yeah, you did fix it.
I hope I did, because that was just driving me
What happened to
crazy.
your frog farm?
My who?
Frog farm you tried to build.
Frog farm?
Yeah, you were like, I tried building a frog farm in my garden.
They all died. Look, I was trying to save them, but I killed them instead.
How many frogs were they?
Like a bunch, maybe like 30, 35. Like, not like the actual sized ones, like the ones that are just babies, you know?
Like tadpoles.
Tadpoles, yeah, that ones. They just dried out and I forgot to put water back, so came back next day and they were all fried open.
They wouldn't let you sleep at night.
Oh, the noise, right?
Yeah.
But frogs are good for the garden because they eat the bad insects, so I'll deal with the noise somehow. White noise. Alright, guys. More issues. More problems for us. Let's go. A rocket is rising vertically. Rise. This reminds me of
School?
memories. At a rate of, which means dH over dt. How do I know it's dH, not dA or dV? Look at the dimension, it's mile. It's not mile squared, it's not mile cubed, and it's rising. That's called height. 5,400 miles per hour. An observer on the ground standing 20 miles from the rocket's launch point. So, should we call this like X maybe? X is 20. How fast? In radians per second. Radian is a measure of what? Measure of the angle. So they're asking for d theta over dt.
D what?
D theta. Some call it theta. It's actually theta more like that. So how fast is this angle growing? This angle right here. It's sorry, what? Oh, they said radians per second. Here's theta. The rocket is at the elevation of 40. Now, they're saying find d theta over dt when the height is 40. When? So it's not 40 yet. For now, I will just call this h. What was the equation for tangent? Opposite over.
Adjacent.
So we're going to say tan of theta is equal to height over 20. But, of course, we're not going to leave it like this. We're going to have to differentiate, correct? So, if you differentiate tan, what does it become? Secant squared. If you differentiate theta, what does it become? D theta over dt. This is h over 20, meaning 1 over 20 times. If you differentiate h, what do you get? dh over dt. Okay, now we're looking for d theta over dt. Now here's the issue. If you guys look at the question, they want us to find how fast in radians per second. And here we have miles per hour. I must make it to miles per second. Can you guys do that part?
Isn't it 3,600 or something?
Yes. 1 hour is equal to 3,600 seconds. Please divide and let me know how much you will get in miles per second. You will get exactly 3 over 2 mile per second. So now instead of dh over dt, I'll put 3 over 2.
Why don't you just put 1.5?
It's okay. You could do that. But they just like fractions more for some reason, but they're both equally correct. Now, my theta is how much when the height becomes 40? Wait, so if the height is 40, my tan theta is going to become 40 over 20, correct? Which equals to? A 2. Do we agree? Okay. Now, have you guys seen the equation before? 1 plus tan squared theta is equal to secant squared theta? It's about time you see it. So instead of tan, put 2. So we're going to have 1 plus 2 squared is equal to secant squared. So 5 is equal to secant squared. Now, why would a person do that? Because you have to come here and you must replace the secant squared with a 5. Times d theta over dt is equal to so what do I have? 3 times 1 is 3 and 2 times 20 is 40. How would I remove that 5 on the left side? Yes, divide everything by 5. So we'll get d theta over dt is equal 3 over 200 radians per second. I was able to do this because you guys helped me. So, you guys know this equation back from grade 1, right? Who took this in grade 1? No? Okay. We have a curve. We have 2 points. We have x1 and y1. Now find the equation of the tangent line. Do you guys see how serious that is? Because tangent line means you must find the slope first. So how do you find the slope? We differentiate that guy. So y prime is equal to what now? Smart. Replace that x with a 3. And you get 30. So you're going to say y minus y1 is equal to m x minus x1. Yeah. And you may leave it like this. Or if you're generous enough, which you guys are, I'm sure, move that negative 45 to the other side and becomes positive. No. Whenever they say find the equation of tangent line, you have to find the slope first. How do you find the slope? Differentiate. So y becomes y prime. X cubed becomes 3x squared. X squared becomes 2x. That's the first x. x1, that's the y1. Replace the x with 3. So 3 times 3 squared, 27. 2 times 3, 6. 33 is your slope, because y prime is your slope. We're going to do y minus y1 is equal to the slope x minus x1. So y is equal to plus 36. Good.